Hey everyone, in this video I'm going to be going over the beginning of naming different carbon molecules in organic chemistry that abide by the IUPAC rules. So this is the basic branched alkane nomenclature that we're going to be going over in this segment. And before we continue, it'd be helpful if we considered these 5 points I have listed right here, because as we go throughout each example, it's going to be helpful if we can identify these different consider points. So the first being what's the parent chain, followed by identifying any substituted parts on that chain. And then we have to figure out how we're going to number our parent chain. And then when we begin naming it, we have to identify if there's any prefixes or suffixes that we have to be aware of. And then what is the alphabetical order that we're going to be listing our substituted parts of our parent chain in. So with that, let's get into our first example. Alright, so in this first problem we have a relatively simple carbon chain. So I'll give you guys a second to try to recognize what this one is called, and then I'll go ahead and try to solve it. So you can very quickly by inspection just notice that the molecule is 100% symmetrical. So furthermore, we notice that there are no substituted groups on this chain. And so those consider points on the previous canvas have been broken down all the way to the very first point of just identifying what the longest chain is, because ultimately that's what this molecule is going to be called. So let's go ahead and number our carbons. We have a carbon 1, 2, 3, and 4. And since this is symmetrical, we don't care if we start at the left or if we start at the right. And so the nomenclature for this particular molecule, one that has 4 carbons, and that is the longest chain, we call this butane. So what would happen if maybe, let me do this in green, what if we changed this just slightly and we got this kind of molecule where we had the same kind of backbone and then we put something right here. How would you name this one? Well, let's start off by identifying the longest chain again. So I'm just arbitrarily going to pick a side. I'm just going to pick this to be our 1, 2, 3, 4. And really the best way to go about these problems is just to pick a side. You might not always be right when numbering your carbons and finding the longest chain, but you'll figure that out as you go along. And you never know, you might be right the first time. So in this particular case, you can notice that this part of the molecule to the right, so that's the part to the right of the dotted line, and then if you draw another line down this way, you notice that this dotted line has symmetry. And so it doesn't matter if I started at this carbon or if I started at this carbon. Both would be identical in how you would name the molecule. It doesn't matter which one you started from. So we started at this carbon calling it 1 and we went all the way down to 4. And so it looks like we have another parent chain that is butane, but we have something sticking off from the butane parent chain. And that would be right here. I'm going to put a star right there. And what would we call this particular piece that's sticking out? Well, it can be rewritten as a C with 4 H's. And we know a C with 4 H's to be identified as methane. And so here we have a parent chain that is butane with something substituted on the 2 position, which is methane, so CH4. So in writing this, we can say that this molecule is, so first we want to write the position of our substituted group, so that's on 2. then what the substituted group is, which is methane. But don't forget there's going to be a suffix because this is a substituted group. So whenever we have a substituted group, we give it the suffix YL. So we have the position of 2, the substituted group is methyl, and then the parent chain is the last thing, and that is butane. So let's change up this molecule again. Let's draw it kind of like this, and let's put that right there, and something like this. How would you name this molecule? Well, again, there looks to be 100% symmetry across this line. So we know whichever way we start from, it doesn't matter what we call our carbon 1. And so I'm going to call our carbon 1 here. Then that one will be our 2, our 3rd, and our 4th. Great, so let's identify some substituted parts of our parent chain, which is 4 carbons. So I can go ahead and write this is butane. And the things that are substituted onto it look like we have, well, at this star, and maybe I'll draw a diamond right there. And so what are these two groups? Well, we have at the star is a methane, and at the diamond we have another methane. And we can go ahead and already name this molecule because we see that we have a correct numbering system and we have all of our substituted groups on numbered carbons. And so we can name this as 2, 3 dimethyl butane. And so why did I put the di part right here? Well, because we have 2 methanes that are substituted onto our butane parent chain, and so we give it the prefix di. Okay, so let me go ahead and underline the suffix there, the suffix here, and I underline that prefix because it would not be right if we just said 2,3-methylbutane. We need the prefix di right here to describe that there are 2 methyls. So let's do another one. What if, let's do another one, and let's make the chain sort of like this. What about this? How would you name this one? Well, unlike the other problems, we notice that this one isn't very symmetrical at all. And so we have to be careful where we put our, or rather where we number our carbons. So we want to find the longest chain. So let me start here at the right. What if I call this carbon 1? This one will be our 2, a 3, 4, and 5. So now it looks like we have a 5 long carbon chain. So let's go ahead and go off to the side and write that this parent chain is pentane, because that is the nomenclature for a 5 long chain. So now we need to identify some substituted groups. And so again, I'm going to put a star right here because we have one right there, and I'm going to use the diamond right there. And so at the star and at the diamond location, we have both methanes. Okay, so now we need to just make sure that we've numbered this correctly. So we have the correct length, which is a 5 long carbon chain, and it looks like we have the correct substituted groups, which are 2 methanes, but we need to number the parent chain in such a way that it gives us the lowest sum of substituted groups. And so that's kind of confusing. So let me just show by example. So if we look at it this way, at the diamond, let me just draw an arrow. At this carbon, or at this substituted methane group, which is on the 3. And so I'm going to put a 3 right here, and that's our methane. So I'm just going to put meth right there, and then at this one, it's at the 4. We see we have another methyl group. And so let's go ahead and add these two sums together. And so we get 7. Okay, well, let's consider if we perhaps numbered it a different way. Just erase this real quick. What if we numbered it? What if we numbered it in this kind of blue color? What if we call that carbon 1? This is our 2, 3, 4, and 5. Well, we'd have a methyl group at this 4 position, and we'd have another one at the 3 position. And so if we do a 2, meth just abbreviated, and a 3, meth abbreviated, our sum is 5. Well, if you remember from the last addition that we did, our 5 is less than 7. So 5 is less than 7. And we want the numbering that gives us the lowest sum. And so we're going to go ahead and follow the numbering of the blue. I'm sorry, we're going to follow the carbons that are numbered in blue. Okay? So in doing this, we are now able to name our molecule. So let's go ahead and notice that our methyls are on the 2 and the 3s. So let's go ahead and do our 2, 3 dash di. Don't forget the prefix because there's 2. Dimethyl. And then our parent chain, which is going to be pentane. And so that would be the correct answer for this particular molecule. So let's go ahead and try another one. Okay, how would we name this particular molecule? Well, let's start out by finding our longest chain. So I'm just going to call that 1. This is carbon 2, 3, 4. We see there's symmetry at this position, so we can go either up or to the left, and doesn't matter. We're going to call that one our 5. So 5 carbon chains are pentane chains. Now we need to identify any substituted groups. Well, I'm going to put dots right here, there, and another one right there, because these are the different positions that it looks like we have substituted groups on. And so we see that this dot corresponds to that number, which is 2. This dot corresponds to the number 3. And this one corresponds to the number 4. And so I'm going to do 2, 3, 4. And these groups are they're methyl groups because you can identify them as CH4s. So it looks like we're ready to go ahead and name this particular molecule. So let's call it the locations of our substituted groups. So those were 2, 3, 4, and then our prefix tri for 3, then our substituted group. So we have 2, 3, 4 trimethyl pentane. And this is the correct naming. Okay, so let's go ahead and change this molecule a little bit. What if we changed it to look like, you're going to have to excuse my drawing, but let's add these things to it. Go ahead and try and name this one. Well, let's start out finding the longest chain. So I'm going to start right here, call that 1, 2, 3, 4, and 5. Well, if you're looking really closely, you might notice that there's another way that you could have named this chain, right? What if we went down to this very bottom part and we call that carbon 1, and then that's our 2, and then our 3 is still right there, and then we can go either left or right because there's symmetry, and we call that one our 4, and maybe you call that one our 5. So how do you know which one is the correct parent chain? Well, when you're looking at something like this where you have two conflicting chains that are the same length, you pick the parent chain that has the most substituted groups on it. And so let's go ahead and let's follow along our white numbers. So following along the white, we see we have something substituted on the 2 position. So I'm just going to put a tally mark. So that's one substituted group. And then there's another substituted group on the 3 position, so that's another tally mark. And then going more along, we have another substituted group on the 4 position. So that's another tally mark. Let's do the same thing going across the gray numbers. So 1, 2, 3, we have a substituted group on 3. So there's our first tally mark. Going to 4, we see there's another substituted group, and so our second tally mark, and nothing else on the 5. And so we see that the white numbering has more substituted groups than the gray does. I'm sorry. So we're going to go ahead and call our numbering the one that has the white numbers. And so that will be our parent chain. So now let's identify, real quick, our parent chain is pentane because it's 5. So let's go ahead and identify our substituted groups. We have carbon that's substituted on these 2 positions, and then we have this chain right here. Okay, so the reds, we know we've had a few of them already, and they're methyl groups. And then our green group, which is on the 3 carbon, and that is an ethyl group because it has 2 carbons. And so now we think that we're ready to go ahead and name this one. So this is the first time that we have something that's not a methyl group that's substituted onto our parent chain, and so we need to consider the alphabetical order that we're going to list our substituents. So noticing that ethyl starts with an E and methyl starts with an M, we're going to name our ethyl group first. And so that will be on the 3 position, so it's the 3 carbon, we have ethyl. So 3 ethyl followed by our 2 methyl groups, 2, 4, dimethyl, and there's our suffix, prefix, suffix. So what do we have? We have 3 ethyl, 2, 4 dimethyl, and then our parent chain, which is pentane. And that's how we name this one. Let's go ahead and go on to another one. Okay, so let's go ahead and try to name this particular molecule. So how would we name this? Well, I guess it's first important to figure out what these I guess symbols mean. So if it's not quite intuitive yet, this is just another way of writing different different carbon chains. So Me is going to equal our methyls, and our ETs are going to equal our ethyls. And I should note that they don't necessarily have to be with the suffix, YL. They could be a methane or an ethane. I'm just doing this for the sake of this problem. And we can go on to, maybe we'll see propyls, or propyl maybe, and then the other one you might see is butyl. So noting those two things, or those few things, let's start naming this molecule. So let's find our longest chain. I'm going to call this our 1. That's our second carbon. 3, 4, 5, 6, 7, and 8. So we have an 8 long carbon chain. So we're going to give that or an 8 long parent chain are known as octane. And that is our longest chain. So we now want to go ahead and try to find substituted groups. Well, I see there's substitute group right there. We have another one here and here, and they're 2 methyls. And then we have some ethyl groups on the diamonds. So let's go ahead and write those down over here. We have at the 2 position, then we have one at the 4 position, and another one at the 4. And these are methyls. And to save space, I'm going to write this right here. So we have 2 ethyls at the 5 position. And now we are actually ready to name this molecule. So let's begin by recognizing ethyl alphabetically comes before methyl. So we'll have our 5,5 di, because there's 2, diethyl, prefix, suffix, then our methyl groups, which are on the 2, 4, and 4 position. And we're going to call that trimethyl, and then our parent chain, octane. So there's our prefix and suffix. So we have 5,5 diethyl 2,4,4 trimethyl octane. Okay, so that wasn't too bad. Let's try making it a little bit harder. What if I have something similar? Again, we'll call that the ME. Another one there. And then we had our ethyl group here, and then some group like that hanging off. Well, a lot of this one's actually the same, but there's this one part that I guess is pretty obvious, which is different. So why don't you guys try answering this problem considering this difference in the molecule? Okay, so we're going to want to begin the same as we have for every other problem. Let's name our parent chain. So to do that, let's call this our 1, 2 carbon, 3 carbon, 4, 5. Should we go down or should we go to the left? Well, if we go down, we'll get to 6 and 7. If we go to the left, we'll get to 6, 7, and 8. So we're going to go to the left. 6, 7, 8. So it seems that we have the same parent chain, which is octane. And it seems like we have similar substituting groups of a methyl on the 2, and 2 on the 4. And then similarly, we have a ethyl group on the 5. And then we have this weird kind of thing. We have this weird kind of thing hanging off also on the 5. And we don't really know what to name this yet. So now I'm going to introduce a few special groups whenever you're encountering, I guess, branched alkyl nomenclature problems. So, some special groups. So if you see, let me do this in a better color. I'll just do it in white. So if we have a group that looks like this, and R is just some arbitrary group down here, we don't care what it is, we're going to call this isopropyl. And so we know now what this group in brackets is. So let's go ahead and name our molecule before I start listing the other special groups. So it's on the 5 carbon, and whenever we are naming some of these special groups, we don't consider this sort of prefix, we only consider the P in naming the groups alphabetically. And so we see that our ethyl group is still going to come first, so I'm actually going to do this in green. So we have our 5-ethyl, followed by our methyl groups, which are the 2,4,4 trimethyl, and then our other group is the isopropyl, which is on the 5. So we have 5 isopropyl followed by our parent chain, which is octane. And so notice, again, I kind of already said this, but you know, this I in isopropyl would come before our methyl group, right? Because I comes before M. But what we're considering in alphabetical order is not this prefix iso. We're considering the more general propyl part of our substituted group. And so that's how we're going to name it, based off the first letter of our more general group, which is propyl. And so our answer is 5-ethyl 2,4,4-trimethyl 5-isopropyl octane. So let me go ahead and introduce you guys to a few more of these special groups. Okay, so in the previous slide I already had shown isopropyl, but there are some other groups that would be good for you guys to be aware of. So what if we had, you know, another group like this, and R is, you know, for the sake of this video in nomenclature, is our parent chain, and we want to name this substituted group. Well, we notice that there are 4 carbons, and so we refer to this particular group as isobutyl. And so I guess the part that you can identify between these isopropyl and isobutyl is this kind of branched out Y, right? Because it might get more confusing when we see molecules like this, or substituted groups like this. And this particular one, where R is another parent chain for the sake of this video, we have the substituted group right here, and we're going to refer to this as sec butyl, because we have 4 carbons, which is our butyl part, and the orientation that they are configured in is where we get the prefix sec. So the other one to consider is this one, where R is a parent chain, and we have 4 carbons. And this one might be difficult to understand at first. So here's our first carbon, our second, our third, and there's our fourth. And so we name ones that look like this tert butyl. Or we can just simply put T-butyl. So another one that might come up, which isn't as confusing and honestly is rather rare, is if, let me just clear some space, is if we have another one where our chain is, there's our R, we have something like this. So again, this looks like a 4-carbon substituted group. There's our 4, if it's not obvious. And you might see this referred to as N-butyl. And all N means here is just normal. So you could see it on, I guess, anything else. You could see N-propyl all the way up to, I guess, even N-decyl, I suppose. I guess that's not so common as you'll see something like N-butyl and even N-propyl, but all it means is just the normal way to write these substitute chains, where there isn't anything fancy going on within them. So these are the last few ones, and these are helpful special groups to be able to identify in case they come up in further problems. So with that, let's do a few more problems. So here we have another problem. So I'll give you guys a second to go ahead and try this one for yourselves. Okay, so let's go ahead and try to find the IUPAC name for this. Well, what's our longest chain? You might think if we started here and went all the way along this way, this is the correct way to go. But if we take a minute to realize that N-PR is just our normal propyl, so our normal propyl, like this, we see that we have 3 carbons that come before our R group, where our R group is simply this kind of straight long chain right here. So if we went ahead and drew this out, why don't I just do that real quick? Just draw it out. So why don't I do that beneath it actually? So we have, that's supposed to be connected, and our N-propyl. So now it becomes a little bit more obvious how to name it, right? So we're going to name this our carbon 1 now, 2, 3, 4, 5, 6, and 7. And so we're dealing with a heptane parent chain. And it looks like we have a group substituted on the 4 position, which is an ethyl group. And so in naming this, we have our only substitute group, which is 4 on the 4 carbon, and it's an ethyl, followed by our parent chain, heptane. So let's change this molecule up a little bit. Let's make it, let's do this. That looks fine. And something like that. Okay. Okay. So I think this works. How would you name this molecule? Well, we learned from the last one that if we drew it out, we see that we have our longest chain to be starting at this kind of N-propyl group, excuse me, and it goes all the way down to carbon 7. Well, if we did the same thing here, we can see that maybe this is our 3 carbon, right? This is our 4, and if we go to the right, we'll end up with 7. So there's our 7. And if we go to the left, the highest we can get up to is 6. And so we're going to go to the right, and that's going to be our correct chain. So our parent chain is heptane again. And we have a substituted group out here in brackets. And so we learned in the special groups kind of section I did before that the way to name this group is tert, or just a T, butyl. And that is on the 4 position. So 4. So let's begin naming this. So we have our only substituted group, which is on the 4, and we have our T-butyl. And then our parent chain is heptane. And this is how you'd correctly name our molecule. So let me go ahead and try making this a little bit harder so I can introduce something else. Let's get a chain that is similar. We have this going on, something like that. We'll keep our N-propyl right there. I'm going to throw that right here. And just because I can, we're going to call those our MEs. So now we need to figure out the correct parent chain for this molecule. Well, if we kind of drew out our N-propyl, that'd be our N-propyl. We can see that this is our 3rd carbon. If we started and called that our 1, this is our 4. If we go to the left, we see that the highest we can get up to is a 6. If we go to the right, we get a 5. And this is not symmetrical, so we have to pick either go up or go down. If we go up, we'll have a 6 and a 7. And let me excuse me, let me do this in gray. If we go down, we'll have a 6 and a 7. And so now we need to figure out oops, and I seem to have forgotten a chain. Oops. And I'm sorry, so this should be 5, 6, 7, and 8. And so now it's a lot more clear which chain we're going to go with. Obviously, we're going to go with the white chain because we have 8 carbons versus 7, and so our parent chain becomes octane. Right? And we need to identify now some substituted groups. So we have this one, and we have one right here. So, excuse me, that's actually incorrect. This one needs to be looked at closer and not make the mistake that I just made. So looking at this entire chain, we see that there's something that's substituted out here off of the 4, and then we have something else that's substituted out here off of the 5 carbon. And so it might be a little bit confusing at first because I just showed it was a little bit confusing for me. These methyl groups are just, I guess, a fancy notation. You can simply take them off and it'd be the same thing as CH4, or CH3, my bad. And so if we did that, we can notice that, well, this is just an isopropyl group, and then on this 5 carbon, the substituted group is also just an isopropyl group. And so we have 2 isopropyl groups, one at 4 and the other one at 5. So we have isopropyl right there. And so now we can finally name this. We have our first isopropyl at 4, our second one's at 5, second one's at 5, and there's 2 of them, so we're going to give it the prefix di, and then isopropyl octane. So this one was a little bit confusing because I had the methyl groups written as Me, which is correct, but it's different. It can trip you up, so obviously go slower so you don't make the same first mistake that I did. But this is how you'd write our molecule if we had, two special groups. You still use the same prefix di, and if we had three, we'd use the prefix tri. So let's do one more set of examples. All right, so in this molecule, I've tried to throw in a little bit of everything. So we have our confusing notation where we have, ethyl written as ET and our methyl written as ME. So for something that looks kind of confusing like this one, it might be helpful if we went ahead and we redrew this. So I'm going to go ahead and do that right now. So I'm going to ditch that ME, just draw that line. I think that was like that. We have an isopropyl group, just like this, and then an ethyl group. And so we have all of this junk, which is, I guess you could say, it's hardly easier to interpret than what's still left, but let's go ahead and try. So finding our longest chain. Let's just call this one up in white. We'll call that our 1, 2, 3, 4, 5, 6. Well, there's another way we could have named this. We could have gone the same with 1, 2, 3, 4, 5, and 6. And additionally, there's even one more way that we can name this molecule. We could, I guess I can do it in red. You can go maybe 1, 2, 3, 4, 5, and 6. A lot of numbers. So let's go ahead and analyze which one's going to be our parent chain based off which one has the most substituents on it. So with our white numbering, we can notice we have a substituted group at the 2 position, so tally mark for the 2. And then we have another substituted group at the 3 position, and there's 2 substituted groups, so we're going to do 2 tally marks. Then we have another substituted group. At the 4 position, so there's another one, and a last substitute group at the 5 position. So there's our 5th tally mark. And let's analyze our gray. So starting down, we have a substitute group on the 2 carbon, 2 on the 3, and then we have 1 on the 4. And so that one only has 4, so we know we're not going to use the gray. And with the red, we see 1 substitute group on the 3 position, and then 2 substitute groups on the 4 position. And so we're going to go ahead and we're going to use our white numbering. Got that out of the way. So now we have to figure out what our substitute groups are. So let me do this in green. Following the white, we see there's a substitute group right here. So this will be our 2-methyl. I'm going to do them piece by piece. And then we're going to go more. We see another methyl right here. So there's another 4-methyl going along. I'm going to skip a little bit. See, there's another methyl right there. And so these are all methyls. So we have more groups. We have 1 substitute group on the 4 position. So substitute group on the 4 position. And that's an ethyl. So we'll put our ethyl like that. And then we have another one that's, oops, and I said that was 4. That should have been the 3 position. Oops. So 3. And then we have another ethyl group that's on the 4. So I guess it works anyway. Alright, so that looks like all of our substituted groups. Let's go ahead and begin naming this. Our ethyls come before methyl in the alphabet, so we are going to write them first. So we have our 3, 4 diethyl, followed by our 2, 4, 5 trimethyl, and our parent chain, which we saw was 6 carbons long, and 6 carbons is a hexane carbon chain. So we're going to add that to our back right here, and this is our answer. 3,4-diethyl 2,4,5 trimethyl hexane. And there you go. So that's the last problem I have for you guys. I've kind of demonstrated the special groups. I've made it important to recognize, prefixes and suffixes, finding the longest parent chain, and some kind of weirder notations like Me for methyl, Et for ethyl, and so on. And then how to put them all in the correct order with that being alphabetical, and also how to figure out the lowest sum for your substituted chains.